And if you want help.
Come back, please. I want to talk now. You're looking at number 10. Oh my gosh. I may have said this. The reason I jump around is I try to get as many videos as possible so you have as much help as possible. So I try to do different problems in different classes to get a wider variety of videos. So here we go, 10. Reminder. First question for the whole room. The first question. This is going to happen all year long. You're going to be given something like that in purple. And the best thing to always, the best place to always start is don't just jump in and try to remember steps. Don't jump in and try to remember what you've done before. Start with the big idea. What is that? Like, at its most fundamental level, why are they giving us this? Like, what is the purpose of that? It has nothing to do with, well, it does have everything to do with the problem, but like, it's more fundamental. If you don't know the answer, it's fine, but does anybody know what that is? And it's actually a very simple answer. What is that?
Basically just like 1 over x squared.
Oh, hold on. Everybody look up. Harrison's going to get a bunch of points for this. He's stumbled into a common misunderstanding. It's okay. All we got to do is keep fixing them. So you can all thank him later for saving you all. Memorize the following phrase for this class, and I don't know of an exception in the other math class either. But sit right here, Colin. But only, look, it's only legal to divide factors. It's only legal to divide factors. So everybody in the whole room, raise your hand and answer this question. On the bottom here, is x a factor, yes or no? Hands up. Yeah. On the bottom, hands up, hands up. On the bottom, is x considered to be a factor of the denominator? Julia Henson. Yes. Julia says yes. How many agree with Julia? 2 points, 3 for Julia. So x is absolutely a factor of the denominator because it's x times x. It's a factor. It's something times something. However, in the numerator, the x is not a factor. It looks like a factor. It looks like ln times x. But it doesn't mean that. It means you take the ln function, of which you studied somewhat, and you put into that function a value of x. So the x in the top is not a factor. It cannot divide with an x on the bottom. That's what you were doing, right? Yeah. You can't divide because they're not factors. Back to here. What is the purple? Let's go, Eli. Now you're on the right track. Look, hey, look. Just back up one level. I think it's best to say, hey, the purple, that's simply a way of finding every single xy pair. And then once you have the xy pairs, if you want to make a picture of them, we call that a graph. But we start with, we got to have xy pairs before we can make a graph. So that's how you find the xy pairs. That's all it is. I'm going to ask that over and over again. Get good at knowing it really quick. And also get good at knowing you can use that equation to find any x. Well, back up. It's xy pairs, but because they're pairs, you can't find one without knowing at least the other. So you can do it either way. You could say, I know that there's a y value of 10. I'm going to use that formula to go find the x that goes with the y of 10. Or more commonly, we can say, I have an x of 5, and I want to go find the y that goes with that x of 5. That's all this is. Don't ever forget that. We use that over and over again. And what I have found is that if you can get good, I'm going to say this repeatedly, if you get good at the big ideas, you'll be very successful in this class. If you just try to skip the big idea and get to steps because you're like, oh, that's a lot faster, I just want to do the steps, they'll fool you over and over again. Okay, so always start with the big idea. 5 for Eli, questions? Cool. Next big idea. We're looking for XY, this is XY pairs. It says, does this function have a right half horizontal asymptote? So now what you should mentally be thinking is this. They're telling you the x coordinates. They're telling you to think of x coordinates that look something like this. The trouble is, there's an unlimited number of these x coordinates. They just keep growing forever. That's what it means to search for a horizontal asymptote. Is just let x grow forever and see if you can see if there's any pattern to the y values. That's all we're doing. Questions? Solid. So, let's see. That means I should be telling the grader that I understand that, oh, this right here is kind of hard to write. This is what you should be thinking. But the way we write this is we write this. So put this on your yellow paper. This little statement in green means exactly the same thing as this big old kind of thought I had over here. Those are the same thing. Questions? So we're finding a limit. So we go right here, number 1. Raise your hand, please. Does number 1 apply? Does number 1 not apply? Why or why not? Hands up. Let's go Jay Capon.
It does apply because x is approaching infinity.
Give you 3 for that. Definitely applies because x is approaching infinity. So Jake, what terms can we compare that are adding? Trick question, kind of.
There's no terms already.
Smart. So number 1 applies for one reason, but it actually doesn't apply for the other reason. There are no terms they're adding, so I can't do number 1. Give yourself 2 if your hand was raised. Jake gets 3 more. Factor and divide. The only factors of the denominator are x. X is not a factor of the numerator, so we can't divide. The only reason we factor is to find matching factors. So we skip number 2. We don't do left-right because it's x approaching infinity. And we haven't learned L'Hopital's rule yet. So we're left to simply do this one just completely in our head. We're trying to find the limit as x approaches infinity of this. So you need to look at the top alone and say, if x were doing this, like we see here, what's going to happen to the top? The top is just the natural log of that x. So raise your hand if you know what's going to happen to these values if we're putting those x's into the natural log of x. Do they get bigger? Do they get closer to 0? Do they get very negative? Do they get very positive? Do they grow rapidly? Do they grow slowly? Do they get close to 0? What happens? This is just memorization. There is no analysis. It's just like you have to know this as a fact. What's going to happen here, Jason?
Is it closer to 0?
3 points. No, but that's okay. What's going to happen here? I don't care. I'll hear you talk. Julia. They do get bigger. Do they get bigger rapidly? Do they get bigger kind of a medium rate? Do they get bigger slowly? Slowly is the key. If your hand was raised, give yourself 2. Julia gets 3. So the top is getting bigger, but it gets bigger very slowly with larger and larger x. The bottom is a power function. It gets bigger also, but it gets bigger faster because power functions grow faster than log functions. So all they expect you to do is make a comparison and say, how do I write this? I don't know how to write it. Don't put this on your paper. I'm just kind of thinking out loud here. So the top is getting bigger. Or you could say the top is approaching infinity. The bottom is getting bigger also, but it's getting bigger faster. So it is also approaching infinity, but more rapidly. That's what's happening. Questions so far? So here's a thought. I need someone to talk with me. I'll pay you to talk with me. All you have to do is converse. Here we go, CJ. So CJ, I'm going to put down a bunch of numbers here. They're not the real numbers, but they show a pattern that's helpful. So here we have a bunch of different x's here. The x's are getting bigger and bigger. We are putting those x's into this formula here that is called natural log of x divided by x squared. So the numbers I'm about to write are not the real values. They're just random, but they show a pattern. So we say that, let's just say the top starts out at 1. And we'll pretend the bottom starts out at 1 as well. They both grow. The top grows, the bottom grows. But the bottom grows faster. So give me a new number for the top that's bigger than the first one here.
4.
Good. So the top grew. The bottom must grow as well, but it grows faster. So give me a number for the bottom.
8.
Cool. So that grew faster. Now we do it again. So that one here, here. So the top grows again.
Is it like linear or exponential?
It's not either, really.
Okay.
So the top grows.
Okay. Like 8.
Yeah, it's supposed to do 9 just to make it not symmetric. And then the bottom grows faster.
Yeah. 50.
That's good.
That's pretty fast.
The top grows.
Good. 20.
There we go. The bottom grows much faster.
Okay, 1,000.
There we go. 3 points for CJ. Okay, those are not the real numbers, but they are the pattern. So raise your hand, please, and answer this. If we keep doing this forever, what number are we headed towards? Hands up. If we keep doing it forever, Caitlin, what number are we headed towards?
Infinity?
If it were flipped, for sure, because the 1,000 would be on top and the 20 would be on the bottom, and we'd be getting bigger and bigger on the top, and so it's just growing. In this case, it's actually doing the opposite. It's a fraction that is getting closer and closer to 0. No worries. How many knew? 2 points, 3 for Caitlin.
So why was Jason wrong then?
I wasn't wrong.
I
Wait,
forgot what he said.
you said it's getting closer to 0, and you said,
But that was just the top. It's just the.
Yeah, that's what the ln was doing.
oh,
The ln is not getting close to 0. The ln is actually, so here's what's weird. Look. Answer this, raise your hand. As x gets larger and larger and larger, what happens to the top all by itself? What is the top getting closer and closer to equaling? Hands up. Hands up. It's kind of weird, but it's true. Friendly. The top is getting closer to infinity. As the x gets larger and larger, the top gets closer and closer to infinity. How many knew? 2 points, 3 for Brindley. What happens to the bottom? Hands up. Kenshin. Also infinity. How many knew? 2 points, 3 for Kenshin. The key difference is the rate. And that's why I did this little weird pattern with CJ to try and illustrate that both can grow, but if the bottom grows much faster than the top, you're headed towards 0. If the top grows much faster than the bottom, you're headed towards infinity. Overall, please.
So, on a graph, what would it look like on a graph?
Without plotting with the computer, I can't say exactly, but roughly, it's going to probably do something like this. It looks exponential. I don't know that it actually is, but
But it's still going up. Hertz.
You can't ever plug in 0 because dividing by 0 would be undefined. So we'll have a vertical asymptote. 3 more. This was not quite right. So it'd be more like this. I think. I'd have to plot it to be sure. But
So if the bottom is growing so much faster, why can't you just think of it as 1 over x squared? Just to make, like, what are you getting?
it will have the same result. It will have the same result, but it's not mathematically correct to think of it that way. Because the top actually is growing. Good question. 2 more.
So does this have both a vertical and horizontal asymptote?
It would have a vertical asymptote for sure at x equals 0. And it has a horizontal asymptote of y equals 0.
Okay.
3 more.
So how do you know that it's getting closer to 0 and not like negative?
Oh, none of them are negative. They're all positive numbers. Because the natural log of a number that gets bigger and bigger and bigger is positive. You just have to memorize that. X squared is for sure positive. With, x's that are positive, x, any x. So it's not negative at all. It's just that the fractions get more and more like this kind of thing. Like that fraction is much closer to 0 than this fraction. And it just, the pattern continues. Sometimes I've done this, which is kind of goofy. I've said if the top goes to infinity, but the bottom gets there quicker, then you're headed towards 0. Other questions? Kenshin, please.
Wait, if x is negative, does that also go to 0?
Good question. Memorize everybody, 3 for Kenshin. You cannot find the natural log of a negative number. It's undefined. So if they say what's happening as x approaches negative infinity, your answer is nothing's happening. There's nothing I can do. The whole thing's undefined. There are no values in this xy. Like I said, this is defined all the xy pairs. There are no x values in this table that are negative. Therefore, there are no y values in the table that are negative. Anybody else? Okay, cool. Oh, please, Lindsay.
Sorry. So can you go over why is it like the ln and the x are not being multiplied? Like what is going?
Oh, that's just a matter of how math notation was invented. So, because they're written next to each other, it appears that they would be multiplied. But because you memorize that this is a function, it's a function, that means the x is inside the function. It's the same idea with sine. That doesn't mean sine times x. It means you're putting the x into the sine function. And then you're doing whatever the sine function does. That's all. That's how they invented the notation. 2 more. Anybody else? Cool. Stop that one.